Okay, in this series of videos, we're going to take a look at the pricing of bonds. So let's get started here and look at some bond pricing basics. First, the value or the price of any financial asset, so not just bonds, but anything you would consider, depends on three things: the size of the cash flows that asset is generating, the timing of the cash flows that you receive by investing in that asset, and then the risk or the risks associated with those cash flows. And that's all going to boil into the discount rate. So bonds have a series of known cash flows that makes it a little bit easier to compute their prices. And those cash flows occur at definite points in time. We have the coupon payments. Those are an example of an annuity. We'll look at that here pretty soon. And then you got the principal repayment. So that happens in a lump sum. So we have these known cash flows, and then finding a bond's price is just simply finding the present value of these cash flows and putting them together. So before we get into some bond pricing examples, let's do a bit of time value review. First thing, we'll look at some lump sum, and in particular finding the present value of a lump sum. As a reminder, a lump sum cash flow is just simply a cash flow that's received at one point in time. To find the present value of a lump sum, we're going to look at this formula here, where the present value is equal to L, which is the cash flow, and that's going to occur in periods in the future with a discount rate, and I should say a periodic discount rate of R. So L times 1 over 1 plus R to the nth power. As an example, what's the present value of $1,000 received 14 periods from now? If the periodic discount rate is 4.55%, we just plug those pieces into the formula, and we get a result of $536.37. Now, I want to right here interject that I don't really want to use formulas. I don't really want you to use formulas. They're cumbersome. It becomes incredibly complex to use formulas whenever we get into more interesting problems. So I'd much rather you use Excel or a financial calculator, and so that's what this next slide kind of gets to. Let's look at some different ways to calculate that exact same present value using Excel and then a financial calculator. So with Excel, we're going to be using the PV function, the present value function. The arguments in the present value function are first the periodic rate, next is the number of periods, the third argument is the periodic payment, and then there's two optional things that you need to insert into the function, or could insert into the function. The fourth is the lump sum payment. You in this case, you're going to need that one. The last argument is the type, and that's just going to be a indicator variable 0 or 1, which tells you when the cash flow is occurring, either at the beginning of the period or the end of the period. Typically, we're going to leave that last argument alone, and the default in Excel is end of period payments. So as an example here, we've got equals PV. The first argument is the periodic discount rate. That's 4.55%. The number of periods is 14. The periodic payment is 0, and the lump sum payment is $1,000. When you stick that into Excel, you would get a result of negative $536.37. So I want to go to Excel real quick and look at that. And let me make this a little bit bigger so we can see up here. So if I enter in those pieces, we get the result, negative 536.37. I want to show you a little bit better way to enter that information into Excel. It's a little bit easier for a user to see what's going on, and that is to label some of your inputs. So present value, future value, number of periods, the periodic rate, and the periodic payment. It's nice to have those spelled out, and then it's very clear for everybody to see what your inputs are. So in this case, that future value, that's the lump sum we're talking about. It's $1,000. It happens 14 periods in the future. The periodic discount rate is 4.55%. There's no payments that are occurring along the way. And so we can use the PV function and then refer to each of those input amounts as appropriate and get the answer. Again, it's 536.37. This bottom area is what I would prefer to see when you're doing calculations, so it's very easy to see what you're doing. And by the way, when you have this kind of a setup, it's very easy to just change any of these single inputs and then get a new answer without going into that and digging around for which thing needs to change. So this makes it for a very robust little setup, and it's easy to change inputs. It's easy to use the calculation over and over. So that is Excel. Let's take a look at a financial calculator real quick. And I'm going to, the only emulator I have is for the TI BA2 Plus. So I'm going to show you how to do that, these calculations in the TI calculator. It's a financial calculator. You need to have one. And if you don't have this kind, you need to figure out how to do these calculations in your calculator. We've got the time value inputs up here, this row with starting with N, I, PV, PMT, and FV. So the N is the number of periods. We've already said that's 14, so I'm going to type in 14 and hit the N, and that inputs the 14 as the number of periods. My periodic rate is 4.55%, and I type in 4.55. I don't type in 0.0455, so that's a distinction between calculators and Excel. I hit that as my periodic rate. The present value is what we're solving for. There's no payments, so I need to put a 0 in there, and my future value is 1,000. So I input there, and then if I click on the PV and compute PV, there we go. I get my answer of 536.37 if we rounded it to the nearest penny, and it is a negative again. Let's go back to the slideshow, and I have a little note here. We want to talk about the conventions for using Excel and financial calculators. We need to pay attention to the signs, the plus or minus signs, and think about how interest rates are handled. So first, with the signs, we want to think of positive cash flows as anything that you are receiving as an investor or as a company, money that's coming to you. And negative signs, negative cash flows are going to be things that are leaving you. So if you're paying something, if you're investing an amount, you would put a negative because the cash is leaving you, going into an investment, going into a project, going into a company. So that's going to be the convention we use, and that helps us interpret these things. So for instance, this negative 536.37, the way we'd interpret that is that we would need to pay that amount today, $536.37, in order to receive that $1,000 lump sum 14 periods from now. And if we did that, we would be earning, in fact, 4.55%. Okay, we're going to pause here, and we'll pick up in the next video with looking at a series of lump sum payments and finding the present value of a series of cash flows. So we'll see you then.